it's 7, 4. We start with. Here we add and subtract rational expressions where the denominators are not alike. So a over b plus c over d, where b and d need not be the same thing. Well, okay, you rescale this by d over d, you rescale this by a over a, d over d, rescale this by b over b. We're left with AD plus BC over BD. And with the subtraction, it's the same thing, only with a minus. AD minus BC over BD. We saw this before with adding and subtracting fractions. So you multiply these two, you multiply these two, and you multiply these two. So you get this kind of crisscross pattern. Therefore my name for it, the rabbit rule. So all right, n plus 2 over n minus 4 minus n plus 5 over n plus 4. So crisscross over the bottom. N plus 2 n plus 4 minus n minus 4 n plus 5 over n minus 4 n plus 4. Well, okay, this expands out to n squared plus 2n plus 4n plus 8 minus, and this expands out to n squared plus 5n minus 4n minus 20 over the same product as before. And okay, a number of steps later, n squareds cancel, 2n minus 5n, 2n plus 4n minus 5n minus a negative 4n comes out to 5n. 8 minus negative 20 is 28. So 5n plus 28 over n minus 4n plus 4. Now, sometimes you don't have to go all the way to the rabbit rule, b times d. Sometimes you can find a denominator that's not quite as big, needn't be as big as the product. Now to do that, we need what's called the lowest common multiple, LCM. You want to find, basically, it's the biggest multiple it's the smallest multiple of both of them. So we call that, it's the smallest number that's a multiple of both. And its complement is the greatest common factor, called GCF, which is the biggest number that's a factor of both. Now people get confused. Okay, look here, 6 and 15. LCM is a multiple of both, and the smallest one that's a multiple of both. That's 30. 6 goes into 35 times, 15 goes into 30 twice, and there's no smaller multiple of both, no common multiple. Now, greatest common factor is 3. 3 goes into 6 twice. It goes into 15 5 times, sort of a complement of this. And so GCF. People get them confused. They think LCM, oh, it must be 3. And GCF, oh, it must be the 30. No, it's the other way around. It's common multiple and common factor. So, okay. So the least common multiple is bigger than both, and the greatest common factor is smaller than both. Please don't get them confused. So I know this works also not just with numbers like 6 and 15, but with expressions. So the least common multiple of x plus 2 times x plus 3 and x plus 2x minus 5, well, it needs an x plus 2, it needs an x plus 3, and it needs an x minus 5, so here it is. But you see, it's smaller than if we multiplied these, because these have an x plus 2 in common, and you'd wind up with 2 factors, but you only need 1. Here, the greatest common factor of x plus 2, x plus 3, and x plus 2, x minus 5, well, it's the x plus 2, which divides into both of them. All right. Which one is this? Oof. All right, so to add 2 fractions, instead of b times d, we can have the least common multiple, also called the least common denominator. And a times, well, how many times b goes into the least common multiple? And here's c times how many times d goes into the least common multiple. Now I call these two things, the LCM divided by b and by d, I call these compensators. They compensate for the new denominator rule. So here we go. For example, 1 over 6c to the 4th minus 8 over 9c to the 2nd. Now the least common denominator, well, 6 and 9 go into 18, 4th power and 2nd power go into a 4th power. So we put 18c to the 4th as the new denominator. Now 6c to the 4th goes into 18c to the 4th 3 times. So we multiply 1 by 3. 3 is the compensator. 9c to the second goes into 18c to the fourth, 2c squared times. So we put c squared as the compensator here. 1 times 3 minus 8 times 2c to the fourth over 18c to the fourth. That's 3 minus 8 times 2 is 16. 3 minus 16c squared over 18c to the fourth. All right, here's some more examples. 6 over 9, 5m squared minus 5m, minus 3 over 5m minus 5. Now, okay, this is merely m times that, so the least common multiple is 5m squared minus 5m, namely this. So that's the new denominator. 5m squared minus 5m goes into that one time. 5m squared minus 5 goes into 5m minus 5 goes into 5m squared minus 5m, m time. So you get 6 times 1 minus 3 times m. Then, so 6 minus 3m over 5m squared minus 5m. Now here, you have an s plus 3 and an s plus 7 denominator, and there's nothing for it. They don't have any common factors. The least common multiple is just their product. So really, we're back to the rabbit rule. This times this, minus this times this, over this times this. S plus 7 times s plus 7 here, minus s plus 3s minus 3 here, over s plus 3s plus 7 here. All right, so you expand this, s squared minus 14 plus 14s minus plus 49 minus, and this expands to s squared minus 9. And after a little bit of arithmetic, it's 14s plus 58 divided by s plus 3 times s plus 7. You have a 3d minus 3 over d minus 9 minus 3d over 9 minus d. Now these differ only by a sign. Their subtraction is in opposite order, so we could flip this around to d minus 3, provided we change this minus to a plus. So 3d minus 3 over d minus 9 plus 3d over d minus 9. This is a common denominator, d minus 9. We add the numerators. This plus this makes 6d minus 3. So we have 6d minus 3 over d minus 9. Eight over y squared minus 16 minus 7 over y squared minus y minus 12. Okay, the first thing to do is to factor the denominators. Y squared minus 16 is a difference of squares. Y plus 4 times y minus 4. Y squared minus y minus 12, after a little bit of searching, gets you y minus 4 times y plus 3. So here are the denominators, y plus 4, y minus 4, y minus 4, y plus 3. Okay, we want a multiple, the least common multiple. Well, it needs a y plus 4. It only needs y minus 4 once, so we put that here. And it also needs a y plus 3, so it's this, y plus 4, y minus 4 times y plus 3. There it is, the new denominator. Now this old denominator, y plus 4, y minus 4, goes into this new one this many times, y plus 3. That's that compensator. This goes into the new denominator, y plus 4 times. That's that compensator. So we get 8 times y plus 3 minus 7 times y plus 4. So that's this. Then you expand this out, 8y plus 24 minus 7y minus 28. And you get y minus 4 over y plus 4, y minus 4, y plus 3. But wait, y minus 4 is in common. It cancels. And we're left with 1 over y plus 4, y plus 3. Here I have x over x minus 2 plus 4 plus 2x over x squared minus 4. This factors into x plus 2x minus 2. It's the difference of squares. All right. Oh, but this is 4x plus 2. 4 plus 2x is twice x plus 2. What do you know? An x plus 2 cancels. We're left with x over x minus 2 plus 2 over x minus 2, a simple common denominator. And so you get x plus 2 over x minus 2. All right, here we have a 93a and b. We have t over t minus 5 minus or divide t over t squared minus 25. So the same expressions, only we have a minus here and a divide here. And in both cases, what you want to do is to factor the t squared minus 25. It's a difference of squares, therefore t minus 5, t plus 5. So here, t over t minus 5 minus t over t minus 5, t plus 5. Okay, this t minus 5, t plus 5 is the lowest common multiple, so there it is. This goes into that once, so we compensate this once. This t minus 5 goes in the new denominator t plus 5 times, so we put the t plus 5 there. So t plus 5 and 1 are the compensators. We get t times t plus 5 minus t times 1. And okay, t squared plus 5t minus t over stuff. And therefore t squared plus 4t over t plus 5t minus t plus 5t minus 5. There it is. Now here I have the same two fractions, only there's a divide sign. So you flip up this up for down. And so we get t over t minus 5 from here. Instead of divide, we get times. Flip this upside down, you get t minus 5, t plus 5 over t. The t's cancel, the t minus 5's cancel. We're left with t plus 5. Okay, I believe that's done for this. Let's stop recording.